school after Labor Day weekend. I hope everyone had an enjoyable and restful break, and we are ready to get back to school. I'm going to continue doing your math lessons on the Chromebook, and you can follow along, and those of you that can come to school can ask questions once you are face-to-face with your teacher, and those of you that are still remote, please reach out during our meetings or send emails asking questions if you don't understand something. We are going to move on to Lesson 6 of our Engaged New York. We're still in 6-3. We're going to continue working on number lines. This time, instead of just having plain integers like 1 and 2 and -7, we're going to add something called rational numbers. Now this we're going to work with a little bit more once we get to what we call Module 1. We're kind of going backwards to doing Module 3. So what I'd like for you to write here for rational numbers is we're going to make like a little bullet right here. And I'm going to tell you what a rational number is. Okay, so remember, if you need to pause your screen to keep up on what I'm writing, please do so. So rational number is a number that can be represented as a fraction. So we're going to write that. Number that can be represented as a fraction. All right, so I'm going to let you write this. If you need to pause the video, please do so that you can write this down. We're going to actually look at some fractions here in just a second. But a rational number can also be a decimal that ends or repeats. So we're going to go ahead and put another bullet right here, and we're going to say decimal that ends. And what I mean by a decimal that ends, for example, so we'll put here example. A decimal that ends would be something like 1, and then our decimal point, and 25, and nothing else. It just stops. A rational number can also be a decimal that repeats. And I'm also going to give you an example of a decimal that repeats. A decimal that repeats would be something that, say, would be 3.145145, and it would continue going in that same pattern, 145145. Okay, so go ahead and write these down just so that you have notes understanding what a rational number is. Like I said, if you need to pause the video so that you can get this written down, please do so. Okay, so what we're going to do is we have to change these fractions. Okay, these are fractions, and we're going to change them into what we call equivalent decimals. Equivalent, you will notice in the word equivalent, we kind of hear the word equal. Okay, so we want to find a decimal that's equal. Now, some of you may already know this, and some of you may not. I'm not going to teach you how to do this right now, but I'm going to go ahead and share with you the equivalent decimals. For example, 1/2, if I wanted to write it as a decimal, would be 0 and 5/10 like this. Those two are equal. They are equal to each other. If I go down to the fraction 4/5 and I want to change that to a decimal, that would be equal to 0 and 8/10. These two are equal. So if you notice, I have an equal sign between them. Okay, now we're going to do 6 and 7/10. 6 and 7/10 as a decimal is kind of almost exactly as it reads. It's 6 is the whole number, then my decimal, and 7/10. Some people may write it like this. Some people may also write it like 6 and 7 with a 0. You can add a 0 on the end if you want. Okay, now we're going to scoot down and we're going to look at decimals, and we're going to kind of do the same thing. This time we're going to take our decimals and we're going to change them to an equivalent fraction. And remember that equivalent means equal. So if I had to change this to a fraction, if I read this, this is 0 and 42 hundredths. So 42 hundredths would be written like this as a fraction. Now, if I wanted to, some of you know I could actually reduce this. I could cut them both in half. And if I cut them both in half, I could reduce it to 42 and a half is 21. 100 cut in half is 50. Okay, let's move to the next one. I have to write this as a fraction. 3 and 75 hundredths. 3 is my whole number, and 75 hundredths. Now I have this as a fraction. Some of you might be able to reduce this. If you look at these two numbers, they both can be divided by 25. So if I wanted to, I could reduce it to 3. 25 goes into 75 3 times, and 25 goes into 100 4 times. Okay, so I could either write this as my fraction, or I could reduce it to that. Okay, so 3 and 75 hundredths, here are my equivalent fractions. Okay, the last one. We have 36 and 9 tenths, or 36 and 90 hundredths, since I have the 0 here. So I'm going to have my whole number is 36. It's in front of the decimal. I have 90 hundredths. 90 hundredths. I could reduce that, and the easy way to reduce that is to cancel out my zeros here, which would mean I have 36 and 9 tenths. Now, you remember we've been talking about number lines, so we're going to actually take our number lines and we are going to try and use these fractions and decimals on our number lines. Okay, so once you have everything written down, you can go ahead and turn over to the next page. If you need to pause, please pause. Okay, so on the next page, we have example 1, graphing rational numbers. If b is a non-zero whole number, then the unit fraction 1 over b is located on the number line by dividing the segment between 0 and 1 into b segments of equal length. Okay, kind of confusing, but what we need to remember is that when we have a fraction like this, we cannot have b cannot equal 0. Okay, so we have to have this be a different integer. It could be 10, it could be 5. Whatever that B letter is right here, it says that's how we're going to cut our segments. And I'm going to show you that in just a second. It says one of the B segments has 0 as its left endpoint. The right endpoint of the segment corresponds to the unit fraction 1 over B. So we're going to actually come down here and try and understand a little bit of what this is explaining to us. They're giving us variables or letters to explain. It says here the fraction A over B is located on the number line by joining A segments of length 1 over B. Well, we're going to look at here is, let's put a box over A over B. A over B means I get to pick an integer for A, and I get to pick an integer for B. Okay, we know that integers are what? Integers are numbers, positive or negative. Well, the integers that we look at here for our very first problem, we have the integer 3 on top and 10 on bottom. Now you will see they've made the number line, but they do not have the tick marks for us. They have 0 and they have 1 and they have -1, but they have a lot of space here because we are going to graph a rational number. We have a fraction. We have to decide where 3 tenths is going to go. Well, according to the top up here in our directions, we have to divide the segment between 0 and 1 into B segments. Well, if I noticed here, B is on the bottom. So we have to look at what our bottom number is. And our bottom number here is 10. So we need to have 10 spaces in here. Okay, 10 spaces. So because I'm going to need 10 spaces in here, I'm going to need to put 9 tick marks on here because this one will be my 10th one. Okay, so go ahead and pause your video. We're going to put 9 marks on this side and 9 marks on the left side. So pause your video and then you can restart it and I will have my tick marks here as well. All right, so hopefully your number line looks something like this. Let's make sure that you have the right amount of tick marks. Remember, our number down here in the denominator is 10, which means I needed to have 10 spaces. So if you notice, watch carefully here. I'm going to start at the 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going to do 10 over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This bottom number tells me how many spaces I need to have. That's going to help me make my tick marks. Now, if you notice, I was not perfect. I have a big gap here. I try to make it as even as possible, but with human error, we're not always going to be perfect. Okay, so we have these, we're counting by tenths. So, for example, this would be 1/10. Well, the opposite of 1/10 would be -1/10. Then we have 2/10. The opposite would be -2/10. Start at 0, we're going to go to 3/10. I'm going to continue doing my positive ones. 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and of course, this is going to be equal to 10/10 because 10 over 10 is equal to 1. Now we're going to go over here and do the negatives. So we're going to have to write very small, and you guys get to hear my dog barking in the background. He doesn't like my math lesson. -8/10, -9/10. Oh, I had to write really tiny. And of course, I can't do this one because that's -10 over 10. Well, -10 over 10 is the same as 1. So these two are the same. Okay? Okay, so we made our number line. How did we count? Well, we had to count with a rational number of tenths. We're not counting by 3/10. We're only counting by tenths on the bottom. So I did 1/10, 2/10, 3/10, 4/10, 5/10, all the way up to 10/10. And then I did the opposites, the opposite of 1/10, the opposite of 2/10, and the same thing. It says we have to locate and graph the number 3/10 and its opposite on the number line. Well, since we made our number line, we're going to go ahead and graph 3/10. So let's start at 0. And when we start at 0, we will move over to 1, 2, 3/10, and we will plot our point. And then we're going to do the opposite. The opposite means we start at 0 and we go the opposite direction, 1, 2, 3, and it's at -3/10. So here we have our opposites. Okay, remember we are not graphing integers this time. We are graphing rational numbers, our fractions. Remember, if you need to pause, please pause. We're going to move down to the next problem. All right, so let me straighten out my book here a little bit for us. Let's see if I get my camera back up for you. All right, so this time we're going to look at -7/4. All right, I think I got my camera situated here. Let's go back here to my problem. All right, so we're going to use what we know about the points -7/4 and its opposite. Now remember, when we're graphing rational numbers, remember we're going to look at what we call the denominator, which is our 4 right here, and that's how we're going to number our number line. So first of all, what we need to do is we need to find the center. So find your center. I always start at both ends, and I kind of work my way in until I find the center. And we're going to put 0 here in our center. We are going to number our number line by what was in the B spot, which is fourths. So the first one's going to be 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, and 8/4. We're going to do the same thing with our negatives. Okay, so we'll start here and do -1/4, which is the opposite, -2/4, -3/4, -4/4, -5/4, -6/4, -7/4, and -8/4. Okay, Use what you know about the points -7/4 and its opposite to graph both points on the number line below. So -7/4. We're going to start at 0. We're going to go over -7/4. Put a dot. And we're going to start here at 0. And we're going to do the opposite. So we're going to go to +7/4 and put a dot. So we've gone both directions. Now, some of you may realize that the number 4/4 is the same as the integer 1, which means -4/4 would be considered -1. 8 divided by 4, some of you know, is actually the integer 2, which means -8 divided by 4 would also be the integer, but it would be -2. Okay, so here's our 0. We are counting by these rational numbers or these fractions, both positive numbers to the right, negative numbers to the left. I went ahead and added the integers to kind of help us out a little bit. So this is actually from 0 to 1. This would be 1, and then we have the integer 2. And we also put -1 and -2. Now, the reason why I put those integers on there is because if you notice, this next question says, on the number line, each segment will have an equal length of what? So if I notice, if I'm going from here to here, that was 1/4, 2/4. So each time I added another 1/4. So we'll put here, we're counting by what we would call fourths. That's what our number line was. The fraction is located between blank and blank. So we need to find, that's why we wrote the integers here. Okay, we wrote the integers here. But remember, the original problem was -7/4. -7/4 is over here. And if you notice where the dot is, it is between, it comes right here, it's between the integers -1 and -2. So we're going to write down here on our book, located between -1 and -2. Okay? Now, when it says explanation, it's wanting to know, for us to explain how we know that this falls between these two integers. And we're going to say the fraction -4/4 equals -1. Okay, I'll let you write that down, and I'm going to see if I can fix the screen here for a second. Okay, so see if I can get this fixed situated here for us. So I went ahead and finished writing our answer for us. I'm going to move this here so you can see. So we had to explain where -7/4 was, in between which two integers. And we said it was between -1 and -2. And I wrote here that the fraction -4/4 equals -1. The fraction -8/4 equals -2. So the original fraction, which I gave to you, which was -7/4, is located between those two integers. Okay? Make sure you pause your screen if you need to so that you can get this written down into your math book, because we will be collecting math books eventually. Okay, so we actually are going to stop here on example number 2, and we will come back to example number 2 on Wednesday. So make sure you have this all filled in, because like I said, we will be collecting math books. If your teachers ask you to do extra math lesson, please do that. Or if your teachers ask you to do your freckle lesson, please do that. And then I will meet you all again on Wednesday.